Welcome to Nameless Debate Radio, where radioactivity is contagious. You can join us in broadening our minds on the Nameless Debates Discord via the link below and even feature here yourself, if you've got what it takes.
Can you hear me now?
Mm-hmm.
Okay. Just gonna make sure this is easy.
Got that ASMR voice going on.
Oh, wonderful. Sorry. As I said. Right. Hypothesis testing is definitely an element of science, but there's a whole bunch of stuff that happens prior and post, right? We have a lot of we conduct a whole bunch of experiments for which we have no hypothesis that we're doing, and it's still valid science. So we know that there's a whole bunch of scientific activity we recognize as being part of the conduct of a scientist that has nothing to do with verification or falsification.
Okay, yeah, so let's say I'll give you 10%. Are you happy with 10%?
I'm saying that there's scientists who potentially do nothing but these
I don't care. Are you happy with 10% of science is not verification and falsification?
I'd say like almost 0% of science is verification. A good amount.
No. Listen. When I say verification, I mean an attempt to verify, as in assuming that a verification could occur and trying to get one.
Yeah, we wouldn't be verifying.
No, but you're looking for a result that you would treat as verifying the hypothesis, even if you don't actually think it technically does.
Well,
for the purposes of your analysis, you say,
right.
Well, I should assume that it is true.
Right. So I would say, I think that the philosophy of science has gone through phases, right? And the earliest phase was logical positivism, and in that phase, at that period of time, sure. But
that's when we laid down the guidelines for what we still do today.
Yes and no. So by the time Popper, there was a shift in how we do science, and a very important one. We realized that we could perform experiments that verify gravity endlessly, right? We could make science about verification. If you did it, right, a valid scientific activity and a useful scientific activity would be continuing to drop rocks year after year. We don't do it. There's no point. See, the thing is, what you're really after, and Popper gets it close, but there are other issues, is that you're really after failures, not after verification.
No, dude,
if you make the purpose, like some people would argue strongly enough that verification itself would be a failure of the scientific method, right? So if you're trying to verify...
Look, I agree. I understand and agree, right? But the problem is that, like, what we're talking about when we say verificationism is we're talking about the proposition that we should treat the outside world as the most important thing in an investigation of what's true.
I think that's called evidentialism, not verificationism. No, it's definitely not verificationism. I'm just trying to... Yeah, that's evidentialism, is it not?
The doctrine that a proposition is only cognitively meaningful if it can be definitively and conclusively determined to be either true or false. Yes.
Where did you... Wait, did you just read out verificationism?
Yes.
Can you do it again?
I'll get you a Wikipedia one this time. Ready?
Sure.
The philosophical doctrine that only statements that are empirically verifiable, i.e. verifiable through the senses, are cognitively meaningful, or else they are truths of logic.
Okay, yeah. So, we don't do that. We can't actually verify something like space-time fabric through any test. We don't actually have any test of it. What we can do, and it's really important.
Listen, dude. A huge function of science is aimed at verifying ideas.
Hang on. We can test the effects, right? A lot of what we do is we test the consequences of a theory rather than the entities they propose. So even when it came to like the existence of an ether, we didn't actually try to discover the ether itself. We looked for the effects of it. Even when it came like proposals regarding space-time fabrics and space-time warping, we don't try to look for space-time. We try
I understand.
to effects of it, right?
I understand.
Yeah.
In a technical sense, when we're looking for it, right?
Mm-hmm.
We're not looking for the entity. We're looking for like evidence that we can like make an inference from, right?
Yes.
Yes, but the point is that like when you look for it, right? When humans think about the world, right? When we're trying to understand it, one of the main things that we do actually intend to use science for is to say this idea is true or this idea is not true. Even if we do not technically demonstrate any such thing, a huge part of humans testing the world is about being able to say this idea is true, so I should like use it.
Right. So there's an important kind of line to be drawn. I think that people are kind of like naive scientists, so we naively do try testings. However, in science, there's a little bit more elaboration what we do. So we acknowledge that we can't test for, we can't directly ascertain whether a graviton exists. Like we can't. There's no kind of we don't have direct access to perception of a graviton. What we can do is test for the effects that the theory suggests. And this is actually going to lean close to pragmatism, right? We're going to say this theory has practical consequences. We test for those practical consequences, right? But we go even a step further. We don't really often test for those consequences. We test for their absence. We ask ourselves, what shouldn't be true? If this theory is true, what shouldn't be true?
Wait a minute. Is that or is that not falsification?
That's falsification, which isn't verification. Yes. So verification would demand that we look for what is true, where falsification looks for what isn't true.
Oh, dude, come on. I said that science was almost completely verification and falsification, didn't I?
Yeah, and I've told you the reason that statement is wrong is because it's virtually zero verificationism, right? And then there's an issue with falsificationism that I want to get to, but I need to kind of step it through.
Midnight.
Right?
I have a small tangential question, please.
Yeah.
Like how do you account for like the information paradox?
That's gay.
You're gay.
Could you explain to me what you mean by the information paradox?
Well, specifically how fucking Hawkins fucking described it. Like if the general rule is information is forever, right? And then we see that pragmatically black holes exist.
Yeah, so black hole information paradox.
Yeah,
right?
Basically.
Yeah.
Yeah, because it relates to how we think about objective reality and the fringes.
That one's a tough one. That one's really a tough one. So, I mean, that's also a sci-fi question, right? In my head, what we do is we have a world, we look for patterns, we guess what causes those patterns, right? And when it comes to something like the black hole information paradox, we now have an elaborate inferment of things that cause things, right?
Yes, but our mathematics isn't dependent on behavioral patterns. Like,
right.
We can have mathematics that describe, higher dimensional objects, even though we can't perceive. So,
right.
I mean, we're kind of like flatlanders when it comes to information. So, like, when you're talking about verification, like, the basic idea of understanding objective reality is we're still interacting with it, right? We don't know of its, like, all the properties of what or where we are. But yeah, tangent aside, continue. Sorry about that. In sync. I think you hate me more.
Your tangent is interesting for its own reason, right? So, like I said, we have patterns. We make theorems about why these patterns occur, right? When it comes to black hole information paradox, what we have is we have a kind of large mesh of different theorems that tell you why we see the patterns in nature that we do. But sometimes they have weird consequences, and the black hole information paradox is one of them. So you have elements of this theoretical ferment that tell you that information is destroyed in a black hole, but you have other elements that tell you that information cannot be destroyed. Conservation of information, if you will. So this is problematic because you have, you've been looking at nature, you've been trying to figure out the patterns behind it, you've made theorems, and you don't agree with each other. They don't play well.
But how do we approach the problem? Like, that's the whole point, right? How do we approach objective reality?
How do you approach? I mean, look, it is a problem, but for all intents and purposes, the physics we have today is more effective than the physics we had in the past. You haven't lost anything, and nothing's going to go horribly wrong.
Well,
for you.
you determine effectiveness on the usefulness and application of how we can,
Right. Yeah. And so you find that something like physics, right, it's more and more useful, right? So it's not like you're going backwards or you're going to be sent back to there can be serious problems in physics. Like you can look at it and be like, holy shit, there's this or that disaster, theoretical disaster. But engineers will just keep on making the cars and the houses. It'll be fine.
Yes, I mean, there is no conceptual wrong turn when it comes to finding out what actually is, because what is real is real. You don't have to pussyfoot around it.
Well, I think you can make conceptual wrong turns. So I think that,
yes, but
depending on how you conceive of science, right? But one could have had a period in time where you say plate tectonics is impossible, right? That's a conceptual wrong turn. The good news is at some point in time, someone else will tell you.
Given how humans interact with objective reality, even if somebody took a conceptual wrong turn and said, everything revolves around the Earth, right?
Mm-hmm. Yeah.
We will still probabilistically figure out that is not the case, because what is real exists when these notions are, falsified.
Oh yeah, I mean, provided there is a external reality, it just continues to be. You'll detect the discrepancy when your instrumentation reaches the point at which you can detect the discrepancy, right? So for a very long period of time, and this goes to Galileo, right? So Galileo's era, there wasn't enough of a difference between his model and the prevailing model of the time. Not enough for people to really jump ship. And so that's part of why he got the treatment he did. There are other elements as well. Tensions between religion and science for one of them. But you can definitely have periods in time where, a couple of theories just run parallel because there's not enough in your sciences to tell which one to pick.
But isn't it like, given what you said, that science gets better over time, right? And probabilistically, what there is will be, what can happen will happen,
Yeah. So that to me it has a correlate in a kind of a much bigger field. So I like pragmatism. I think that science is kind of founded on it, in my little conception of things. And under pragmatism, just outside of science, so we can actually step back and out of it, right? Under pragmatism, as long as you constantly think about practical consequences and you're constantly kind of fitting you're fitting your ideas of the world to what you see. If you keep doing that, there's a thought or an argument given by Peirce right at the start of that whole school that says that we converge, right? It's convergence.
But aren't you more susceptible to what's it called?
Yeah.
If you're pragmatic, aren't you more susceptible to intuitions? How if somebody doesn't have an overview, they have an intuition, and they're intuitively wrong most of the time if they don't have an overview.
Oh, of course. It's not a very the point of convergence is the crazy long run. We're not talking about even my lifespan. We're talking over hundreds of years with a large number of people trying to get theories that better fit what we observe. Some people are going to do it better than others, and the ones that do better, we kind of keep, and then we, as that keeps happening, the hope here is that we kind
But
of
it's like
converge.
you have
So,
to.
Hmm?
But what we convey and what we observe is like really different, and like unless we
Yeah.
can upgrade our, upgrade what we convey, like the evolution of language, right? We have like a threshold where linguistics ends, but there's still things out there.
Right, you're right. So there's the English language isn't perfect. It isn't good enough at some points in time. That's where math steps in.
But it's the
Maths
best
is
one
like
yet.
what? English is very useful.
Yeah,
Very
but
good.
math is like,
Um,
it's transcendental.
I guess, yeah, if you wish. My bigger point of saying is that it's kind of better. It's like if you wish, it's like it takes out a lot of the ambiguity that exists in natural languages, just discards it, right? Focuses down on the issue of counting things, right? Calculus, right? That's what the word calculus means.
Well, quantification, but yes.
Yes,
Yeah,
it's numbers in space.
Yeah, it's so that beautiful precision design. If you wish, maybe a different way to think about this is, natural languages are natural, right? They seem to just spontaneously occur. People use them, right? But we have designer languages, right? And math's not the only one. Our computing languages.
Music is like numbers in time.
Yeah, I guess. I mean, I wasn't thinking music.
It definitely is.
Yeah, sure. I was more thinking of programming languages. Designer languages are just really good at what they do. Like they are, like if you ever toy around with programming languages, they're beautiful in their own way. Really are. They too.
Yeah, I would agree with that. For instance, Python is a fucking sick language.
It's great, and you got to give respect for the other languages, even though they're like, whether you love or hate them, they when they're used for the purpose they were envisioned for, they're usually kind of good at that. And there's a whole bunch of them. Like, depends on what you want to do. These designer languages, they've had work done on them. Like math itself is this thing that we have been refining over a long period of time. Things like set theory they themselves kind of are analogous to scientific, if you wish. People look at issues in mathematics and they think of new ways to handle it.
My dude, I don't know how this has happened, but like you started giving the argument that I was talking about before, dude.
Okay. Maybe
I'm
it's
sorry
just
about
maybe
the
it's mistake. No, it's cool. I'm happy. But anyway, yeah, you get this kind of progress thing. And I think the reason you see progress for me personally is that there is in fact a reality, right? I do actually think there is a reality. And as long as you are fixated, you're like straight up fixated on trying to understand it. I'm fixated on it, this other guy's fixated on it, and we're continents apart, right?
Yeah.
As long as we're kind of looking to solve the same kind of problems, we're going to start writing out the same scientific. We really are. It's the same world, so you're going to start writing out the same stuff. To me, it's super normal. Like it is. Like I look at the simultaneous invention of differentiation and integration by Newton and Leibniz, and I'm like, that's the kind of thing you expect to see. That's really the kind of thing you'd expect to see in our history if you're expecting convergence onto, because there's reality right at the end, and everyone's trying to think about it. Mathematicians are trying to solve problems in math.
That's the whole
converge to
thing,
the same
right?
solution.
Our initial thing about mathematics was it correlates to reality so well, right? And then it correlates to our imagination so well. And
imagination, maybe.
Yeah, it's really it's like it's vaguely defined.
I don't know, like apart from that, like I've never actually had anyone contest the proposition that physics is applied mathematics. Like it seems pretty clear to me that that's the case.
I can see.
Listen. Like I use it in a larger argument where I say that all sciences are the same, and you can give like a categorization of it, right? So like, basically,
mathematics is the deconstruction of time.
Listen, like sociology is the study of complicated like psychosocial interactions, right? And psychosocial is just like psychological and social. So if we take out society, then we have psychology, right? And psychology is just complicated neurology. And if we go to what like neurology is made of, right?
Yeah, I know.
Neurology is complicated biology, and then biology is complicated chemistry. Chemistry is complicated physics, and physics is complicated math.
Information. It's information. It's complicated information.
I mean, there's definitely a school argument called that believe in emergency, right? Emergence,
Yeah.
emergent phenomena. Tied to the words a bit bad, but emergent phenomena. And if you're an emergentist, then you can't reduce. Like you can't step down like that. You'll have an element of mathematics present in physics, but then it'll just be content. And it doesn't reduce.
Well, you can associate the.
Oh yeah, I'm a reductionist, man. It collapses.
Yeah,
okay,
it's like
yeah. If you're a
fractalization, right? It's like fractalization. You're understanding like the composition as well as the entities, and like making an overview of it, like not
fractalization.
Like an aspect.
Nah, just it was a bad leap. Like I know what he's trying to say, but it was a bad leap, and I don't want to even try to explain it.
Oh, I was gonna just point out fractals, just what's happening.
Yeah,
it's just that it's self-similar. Okay, if you're a reductionist, then yeah, I can totally see why it is that you reach the view you do. Yeah, under a reductionist stance, and yeah, everything kind of just collapses. Everything's complicated mathematics.
I mean, yeah, our universe is pixelated.
Really?
Yeah.
What makes you say that?
The Planck length.
So the Planck length, and I actually made this mistake recently, so it was more like I learned error because
it's a theoretical distance though, because
the Planck length. The Planck length isn't like the minimum distance, or isn't like the pixel pitch of the universe.
But it can't be indivisible anymore.
No, it is. You can divide further. The only problem is, below the Planck length, you need quantum gravity. It's basically the line at which our physics ends, and we can't process it. There's just not. We don't have the math, like straight up.
Exactly. Therefore, it's pixelation because that information cannot be accessed.
Terrence. I think he's saying it's not necessarily pixelation, because maybe it could be. We just don't necessarily know.
Yeah. We are talking about like below the Planck length, for example. It's similar to talking about what's inside the event horizon for a black hole. Our current physics doesn't have the ability.
Well, do you know what a naked singularity is?
Yeah, I know what a naked singularity is.
I mean, that would be really interesting to see.
It'd be fascinating to see. Like, it would mean so much to us. There's a lot we could learn. We haven't, to memory, I don't think we've discovered yet.
Yeah, we haven't, but we're seeing black holes form. It's like we just saw a black hole form. So like that's pretty groundbreaking.
Yeah, there's a really good article on Planck length that I saw, and it was just really helpful. But this is about.
Do you know about the E8 lattice?
The E8 lattice. It feels like I feel like I've heard that before, but I can't release it.
Okay. So it's like it's on this theory called what's it called? Quasi-spin network. Like it's a theory on quantum gravity. One of the theories of everything. It's like a geometric description of all this elementary particles. And everybody's dead.
No, nobody's dead. I'm just trying to pull you that diagram I was talking. It's not going to make a
And I have a police alarm in the background.
Wonderful. So that diagram there is absolutely hell. It probably isn't as intuitive as I feel it is, but this is the question of, say I had something and I wanted to I wanted to bounce a photon off it to figure out if it's there, like just to figure out if it's there or not, right? I'm trying to localize it.
Yeah.
Now, there's bounds to what happens. So if the object is, if I'm trying to locate an object that's very small, I'm going to need a wavelength of light that's as small as it, right? So the wavelength of light has to be on the same scale as the size of the object. And the wavelength of light is kind of determined by the kind of energy you're pumping into it, right? Or as we would say, the amount of energy in that photon. But we reach a new problem. With Einstein hanging around, what happens is as you pump more and more energy into a photon, it gains a kind of virtual mass to it. And you can actually get the point where the photon, funnily enough, collapses in a black hole. And instead of you being able to bounce a photon off the object,
how do you?
right?
Wait. I have a question about the diagram. But
Yeah.
I understand the photon example.
Yeah.
Just like how do you correlate like the virtual particle interactions with this diagram?
Forget virtual particle interactions for this. That's not part of this. This is like in an idealized vacuum without you having to screw around with anything happening. There's no quantum foam, no virtual particles that are screwing, not even heat, right? This is just a very small object that is even jittering. For some reason, it's at magic absolute zero.
Sorry, Planck energy and Planck mass. Is it like negative mass? Like white holes, right?
Ignore Planck mass. Energy, just Planck. Ignore those two lines. Just a Planck line. That's like fascinating here because it's the magic line on this.
Yes, but what is underneath is more fascinating because what we think is underneath is more fascinating.
Okay, so you're right. I guess that's a fair question, right? So underneath the blue line, we can't yet explore that because the amount of energy required is more than exists in the entire universe, right? And underneath the red line, we can't go there because instead of you being able to test the object by bouncing a photon, you hit it with a black hole and you obliterate it, right? So what will happen is that your photon, you fire it, it becomes a black hole and passes straight through your object and consumes your object, right? Meaning that you don't get the ability to test it. So under the red and blue lines, right, we have a serious problem because our current physics indicates to us that we have a measurement issue. We can't test it. On one end, you need more energy than exists, and on the other end,
are you aware of the
black hole out?
No, the hologram.
Yeah, those.
Well, I think I'm getting a call. Wait, I'll be right back.
Sure. Oh, some high level stuff. What's this?
Yeah, Terrence is a bit of a memer.
I mean, they're okay questions. It's just really.
No, I know, of course.
They're like deep end questions. It doesn't make sense until you've like done.
The issue is that he doesn't like ease you into it or take you to dinner or anything. He just sticks his dick in you.
Yeah, pretty much. You jumped in at a weird point. Instinct's just talking about his personal fetish. That's all.
Oh, okay.
No doubt, dude. No doubt.
Yeah. No, it's like that's what I'm talking to, like biology or something. You can get these topics that are high level that the amount of assumed knowledge to actually explain them is really high. Like it's even like the Planck length, the assumed knowledge here is like you have some on the relativity and quantum physics, and the whole reason you get this problem is that they don't gel well at ultra small scales. You get absolutely absurd results and it just fails. It's my favorite example of science being kind of not internally consistent, or at least not as internally consistent as people think it is. And that's not really a problem. It doesn't have to be internally consistent.
Well, I mean, I think
to be usable.
Yeah, I mean, I think it doesn't have to be completely consistent to be usable.
No, it's definitely usable even in a kind of broken state.
Yeah, I mean, but the point is that consistency definitely characterizes the utility that it manifests.
Oh, reliability, right? Like it needs to actually be like Newtonian physics needs to actually be reliable. But if it's
I don't think reliability is the right word, though.
I think it is. You got reliability.
I don't think so.
Integrity.
Sure, but not consistency, because consistency entails
consistency is the consistency is the correct word.
I like integrity.
Like the fact that you can rely on it is secondary to the fact that it is reliable.
So reliability, as I'm using, is just the quality of being trustworthy or
no. But the thing is that for it to be trustworthy or perform as something that you can rely on, right? It has to actually be trusted or relied on, and that's subjective. That's not the correct word for the property that we're talking about, which is the presence that allows you to rely on it. And
I know what I think. I got a better word. No, sorry. I think I know what you mean. I just that way. Yeah, you'd be talking about external consistency. Yeah. Science has issues with internal consistency, has good external consistency.
Oh, well, I mean, realistically, I think it's like insofar as it has poor external consistency, it's because it has some problem with its internal consistency. And so, like, if we can say that it has good external consistency, then it probably has pretty good internal consistency as well.
I mean, quantum gravity presents a situation in which you get an analog to absurdo ad reductum, and it's really hard to talk of internal consistency in the presence.
Yeah, but that's something we don't understand yet, right?
Of what we do
like
understand.
No. We have different models that don't agree, and we don't know what's happening. That's what you mean when you say we get an absurd result.
Oh, so
like
the
we
don't
know how to explain what we think is happening.
What I mean might be the same as what you mean, but I'll say it anyway. So what happens is you can run the math, right? The math will function just fine. It doesn't give a shit. But then it spits out infinities. So then you look at it and it's like, okay, we don't have infinities happening in the real world. So the math associated with the theorem is dysfunctional. So at some point in time, something's kind of broken down and just. And
that's what I mean, though. You don't know what it is.
So
yes, but isn't our best guess to correlate it with causality?
Oh, what?
Is our best guess to correlate our findings with causality?
I heard you. I just
Terrence, you just got fucking roasted.
That hurt.
He heard you. You were just fucking talking nonsense.
It's just correlated with causalities like that.
It's the thing he does, right? He's not completely retarded, but he just says things that are so out of place.
What do you mean by that? Like, what are you trying to tell me?
Completely retarded, dude. Okay.
Go ahead.
Damn. I said,
Sorry, go ahead.
We correlate our findings of physics with logic and most usually fucking causality, but now we have subatomic physics where that doesn't work all the time. But in order to decipher objective reality, right? Don't we have to correlate our findings with causality? To understand object permanence, to understand basic functions of space-time itself.
Right. First things first. You might actually enjoy reading about quantum logic. So there is a variety or school of logic that functions just fine with quantum physics. You just have to change logic itself. Or change some of the base assumptions, and then you're good again. Kind of what you do, really. Logic is usually logic itself has purposes, and normally mathematics is akin to programming languages. When we say mathematics, people think of it as a homogeneous thing, but there's actually a few different schemes that you can use, and they're really powerful and different.
Variables.
Things. No. No, basic axioms. So Euclidean geometry is base. You know, when most people talk about maths, it's talking about that, but there's different topologies, there's different
Exactly.
entire
And I
systems.
When you talk about math, you do not have to only talk about Euclidean geometry, though.
No, you don't. But it's not a homogeneous group. So it's like when you talk about logic.
Math,
when people
though,
talk about
math,
logic,
all of the disparate
Yeah.
subjects of math
Like,
are
fuck the colloquial.
homogeneous in some sense.
yeah, but it's like
the
having
the way that they operate is the same, even if you change some of the rules around.
Well, I mean, some of the operations are the same, but like
No. I mean, like the function of how operations work fundamentally remains the same.
No.
Dude, math,
So
math describes like what there is and what there could be.
Not what the functions are. I mean the fact that there is like a thing that defines like a set of phenomena.
What? A thing that defines a set.
Yeah, so a function, right, defines like a range of phenomena.
Oh,
depending on the
definition
variable.
of So the definition of like the mathematical concepts they haven't changed. Yeah, I agree with that.
Yes, that's what I'm saying.
The axioms can change, and the some of the properties change fundamentally, like change dramatically. Like something that's so it's true in one system can be false in another, so on.
Yeah, like so I think what I'm saying is that like despite the evaluative differences, right? What we're talking about when we're talking about like mathematical systems, we're talking about systems of like rigorous language that we use to talk about these objects, and the fact that, for instance, you can talk about the objects and derive conclusions that are true and false is like something that you can do in every type of math, even though like the way like what you're talking about specifically and even sometimes the rules are different. You're still saying some things are true and some things aren't, for instance.
Yeah, that's...
And like the way that you work that out is still according to the set of rules. You're just saying the rules change, and I'm like, okay, but for instance, the rule that you have to follow the rules, that doesn't change.
Oh, yeah. I mean, yeah, the meta stuff change.
Mm-hmm.
So like our axiom, like I said, the concepts aren't changing, right? An axiom remains an axiom. So
of course, no, but I think what I'm saying is that the meta rules are what make the disparate what would you say areas of inquiry in mathematics homogeneous, because they all follow the same meta rules.
So I like the way I understand what you're saying is like the mathematical concepts which we teach in school using English, and those are fixed, right?
Mm-hmm.
So like the idea of addition can be fixed, or that 1 + 1 = 2, or
yes,
one,
but
those can
like...
be kind of fixed in nature, and they're not fixed they're fixed in this weird way that's kind of, it seems to be at a higher level. Like there's some kind of...
Math describes information. Information doesn't necessarily have to have meaning. It just is. So if you're describing something that is...
I'm not sure what you think you mean by meaning, Terence.
I mean, you might think I might not know what I mean by meaning.
Do you mean to say subjective significance?
Yes, objective significance as well.
Okay, but significance, that's who cares? That's a vacuous statement.
Well, we care about significance.
Yes, but that's not the point of the discussion. The point of the discussion isn't to figure out why we should subjectively think of it as significant. The point of the discussion is to talk about whether or not what we're talking about can be signified.
Yes, it is being signified.
I'm confused about where this is going. Sorry.
Yeah, dude, I'm really confused as to the words InSync is using.
How about this? Can I say that language is communicative? That's its purpose.
Mm-hmm.
Is that okay with both of you? That's all I'm going to say about it. Language communicates. That's what it does.
But is mathematics limited to conveyance?
Yeah. If something... Everything in maths conveys something.
Wait. Let's be careful, right? So math, as in like the subjective system that we're using to describe the world and convey the world, that is all about conveyance, right? But like when we're talking about math, we're talking about systems that we use to describe some specific thing, right? And like in the same way as like when we're talking, like when we're talking about physics, right? We're talking about the models that we have that actually correlate with the way that the world is, right? So when we say physics, we mean two things. We mean the models we're using, and we mean the bits of the world that the models are matching up to.
Yeah.
That's the other type of physics, is the actual mechanics of the world.
Yes, but dude, information. That's all there is.
Ah, fuck, Terrence. I'm not gonna get into that. Like, I happen to know that, and you're like.
There's more than information. What do you mean by information, Terrence? What are you trying to tell me? What are you trying to say?
Terrence doesn't even know, dude.
Yes, I do. Well,
Okay, what's
not
information?
yet, but well, it's discrete properties of elementary entities. Discrete properties of elementary entities.
Close, but no cigar, my dude.
Nigga, fuck you, nigga. I'm not like I'm still working on it, dude. Like I don't hold absolute certainty.
Someone's a salt lord.
Anyway,
Yeah,
I think that all the language says convey, all of them, forms of it convey something. You're right. I think I know what it means, and yeah, I don't normally call so there's physics, right? But what it's just matching is what I call reality, right? I don't actually designate it as physics.
But don't we mean like when we say like that there are different fields of science, we mean that the world has different like classes of phenomenon, right?
I would say that the classes are something we're imposing.
Characterization.
But like we can't be just imposing them though, because we can use the classes to differentiate things about the world that actually become pragmatically validated.
Well, we characterize different phenomena and categorize them.
Yes, but it's only insofar as different that we're able to do such a thing.
I mean, we're able to do that.
It's different to us because of the sensory ratios it produces.
So, like for me, right?
The behavior is a little bit different, don't you think?
Yeah. So, I mean, okay, an example of this, right? Is I look at it, I see 6 different colors, roughly. Yeah, I think it's 6.
Mm-hmm.
Is it 7? 6. All right, I see 6 different colors. But those are like the categories, concepts that I'm forming. In reality, it's just a continuous spectrum, right? And I suspect that, especially for your argument, right? There's no real distinction. It's just like all those phenomena are just part of just a big reality. We divvy them up because it's just what we do, right?
No, but why is there utility in that, right? And the reason that there's utility in it is that even though they're all the same big reality, right? The parts of reality are like it has reality has like many different levels to it, right? Different like layers in which like different mechanics are instantiated, and though they are all the same thing, reductively they're all based on the bottom ones. It builds up
properties,
right? Yeah, there are actual differentiations to be made, but they're phenomenological because when you don't consider any particular perspective, you see the thing and it is just one thing, right? Because you're not paying attention to the layers. You're just saying, well, how many things actually are there? And the fact that there are layers in the thing is irrelevant.
Insync, could you elaborate on the main thing we can learn from understanding higher dimensional topologies?
I'm not that good with topology.
What can we understand about lower dimensions?
Dude, I'm not that good with topology. Spatial reasoning is not my forte.
Oh yeah, sorry. Fuck. Sorry.
Let me think. So, I'd say that the reason you see the divisions in science that we do is because of what it is that we're doing, right? It's because we are trying to model the world. So if you're trying to model the world, you're gonna find that you don't. Say I want to model a sand dune, right? I don't need to go as far as atomic theory. I can actually model it much more. I don't need that much information. Just modeling
Well,
it.
it depends
can
on
be
the
done.
level of understanding, right? We model using understanding, not perception. Well,
Well,
we
no,
Also,
it's not that.
also, it depends on the level of accuracy that you're requiring from your model. Like a sand dune is a clever example, right?
Some dude, nigga.
it's pretty clever.
No, it's So wait,
No,
there's a bit more.
It's a
What I'm
clever
saying.
example because it's made up of these tiny particles.
Yeah.
Who the fuck is that?
Yeah. Okay.
That's so fucking irritating. Who the fuck was that?
It's a troll. He's getting all the fucking roles. Ban him right now, dude.
You mean what we debating?
Don't do it, guys. I'm
Oh.
here to debate. I'm here to debate, guys.
You ban him.
Dead.
Bitch got wrecked.
Fucking weed out the trolls, dude.
Okay. So wait, what was I saying? So yeah, I like the sand dune. So what happens? This is within the theory themselves, right? Is if I want to talk about sand dunes, I don't need to talk about quantum effects because they're not only do I not need that level of accuracy within the theorem themselves. We
Oh no, dude.
believe
Wait.
that quantum effects are what we say blurred out by the time you hit the macro level.
Yeah. I wasn't saying like there wasn't some utility to the analogy, but it seems like when you're talking about a sand dune, which is like by its very nature sort of nebulous with regards to the form, because it's pretty hard to account for the totality of it. You know, exactly how many grains of sand are there in a sand dune, and how do you make sure that you don't lose any? You know what I mean? Like, it just seems like. Pardon?
I mean, for what it is that science is, right? So science is like this predictive pursuit. So
Of course,
if it's
but that's kind of what I mean,
like-
right? Because like, if you're using a model of sand and like using it on the environment, the margin of error is going to be understandably a little bigger because it's very hard to keep track of sand.
Unless we fucking define the scope of composition and entities, like the composite and the entity, right?
What? I mean, okay, wait. So let me get this. Right?
Well, just one sec, man. One sec. Terrence, try thinking for like 5 to 10 seconds more before you start to speak about how you might make it more understandable to the people you're fucking talking to. Because it's representative of a trend that Midnight repeatedly says "what" as soon as you say something, dude.
Yes, I'm sorry. Let me work on that.
It's just that like I don't want to have to spend too much effort deciphering what you're saying. That's all.
Yes, I'm sorry. Yeah.
I know
No,
it's a
it's
problem Julius has with him a lot. That's all.
Yeah, it's fine. Whatever. Just take maybe more time would be good. So what I'm saying, yeah, I like the sand dune idea. So say you're like a dunologist and you're like, hey, I want to just talk about how sand dunes move and all that, the shapes they take up and all that. There's a question first about precision. Like you might just not need that much precision. And secondly, some effects just become irrelevant at certain scales, right? So like string theory is pretty much wholesale irrelevant to sand dunes, right?
I think that's what I was saying there, because my point was that like it's a clever example specifically because it limits the degree of accuracy you're going to want to ask from the model. You know what I mean?
It's not just accuracy. So I'm saying there's like a little bit more. Some stages you could use quantum physics, but quantum physics itself tells you that it becomes irrelevant at the macro level, right? It doesn't bleed up; it disappears. Like quantum sand dunes don't phase to each other, so trying to model it like that is just unnecessary. Like you're putting all this effort and you're gonna get nothing. Like it's not even like you get more accuracy; you get nothing.
No. I understand. I was talking about like separate from the way that it applies to specifically the quantum stuff. You know what I mean? I felt like it's sort of like I feel like it unfairly limits the experiment in like a subtle way because sort of like you're like putting a hard limit on exactly how many decimal places you would ever need for this kind of thing. You know what I mean?
Yeah, I'm not even, but I'm personally not thinking of decimal places, so it's not an accuracy issue to me. So if I'm talking like biology, right? Like how do muscles work?
No, I
I
just
don't-
mean like the probability that your prediction will be accurate, though, based on like how well it normally does, right? That's
Right.
based in a big way on like what the margin you're using to call something an error is.
Right. And I'm just saying that like what happens is this is gonna be weird. Reality has a touch of chaos to it and fuzziness, right? So there's error.
Reality or phenomenological reality, dude?
Yeah, there are different orders to reality, dude.
Oh dear.
Do you
Okay,
mean
I'm
reality
just
or
gonna say
phenomenological reality?
I'm just gonna say that as far as we understand, right?
No. You just say like
Uncertainty is baked in at a very basic level, right? Because it's baked in.
no.
Not
No.
really.
Sorry.
Just as the
uncertainty
sand
principles?
dunes, you're not uncertain of the form of the sand dune, are you?
No, that's what I mean.
Yeah.
So the uncertainty principles of which there are actually a couple, right?
Yes. Look, I understand, but the point is that like the fact that from the perspective that we're using to evaluate the world, like we're always uncertain about it, doesn't mean that the world is uncertain.
Ooh.
It doesn't mean that it isn't either. Like that's indeterminate.
No, but the point is that that's not evidence to think that it is uncertain.
At its fundamental
That
level.
is evidence to think it's uncertain. Like you
No, it's
generally
not.
would
Isn't.
assume that.
Not at
It's
its
not.
fundamental level.
It actually isn't, dude.
Okay, so
That's
So
a
we have,
fallacy
like-
of composition.
what? No.
It is not.
Okay,
It is. It's called a fallacy of composition.
hang on. Okay, when I say reality, I'm saying this from a materialistic perspective, right? Everything's composed.
No, but I asked you. Do you mean the like phenomenological experience of reality, the sum total of
Right.
subjective
Linear
experience?
timeline of causality, dude.
Or
mean
do you
that,
mean
right?
like? Do you mean the actual thing itself?
Like the whole blinking cosmos.
Okay, so okay. When you're talking to me, the actual thing itself is something no one ever understands. No one.
But I'm.
Like
But
none of us ever
I'm
had
just
that
saying.
in.
I'm just saying. Like when I'm talking about the world, I'm differentiating what all of us know from the thing that we do not know.
Okay, so I do use the Kantian distinction for this, right? So there's the phenomenal world, and then
But it's not.
God,
it's not.
awful.
It's not
But
unknowable.
that-
That's
that is unknown, like straight
no,
up.
no.
unknowable,
See, that's the
right?
thing. Yeah, I accept. That's what Kant thought, right? What I'm saying is,
Yeah.
it's close, right? There's phenomena, and then there are things that you don't know yet, and some things that you can't
No,
know.
no.
But the distinction between the two things is something you don't know how to differentiate.
Right.
True.
So that's
True.
not what I'm saying. The phenomenal world is what we have access to.
Yes,
You
yes, I know. And here's what I'm
know
saying
it's
is,
something you
whenever-
never have
Access to more.
here's what I'm saying, dude, is whenever someone tells me that we can't know X thing because that is noumena, right? I'm telling them that to say that X thing is noumena is to claim something about noumena. Right? So, like, it's never a good contention. You can't say, well, that's one of the things we can't know about, because your proposition is actually a claim to knowledge about the thing.
Okay, yeah, sure. That's the one thing we know about it,
That's
right?
like
But we
that's like a
don't- we don't-
threshold of linguistics on the domain of knowledge.
Yeah. That's actually not a bad answer. Yes. You're right. So,
Everything just exists, bro. And we're
Like,
just
there's definitely stuff that we can't figure out, but like, I don't think there's a good reason to think we can't figure out what the basis of stuff is, because like, from what I understand of what the world is, the basis of it is everywhere. Like, it's instantiated in the multiplicity of complexity that we exist in.
it's
Everything
pretty
we're
geometric,
looking
bro.
at, everything we're looking at is the basis. We just have to figure out how to see it properly.
And how it correlates to other orders of reality.
Like, when people say that, like, when we're talking about things like
Okay.
ontology and metaphysics, we're talking about things that you cannot know. I'm saying, like, dude, there are things all around us. What we're talking about is what it takes to be a thing. So, like, surely we can look at a bunch of different things and maybe talk about it.
Yeah. So what I'm saying is I put up what I mean by new, right? So I'm using the metaphysical sense of this. The metaphysical noumenon is something that we won't know the details of.
No, but
right?
what does that mean?
We
There
won't know
are
the
no
details of it. So the
Okay.
problem is that it's independent of human sense and or perception, right? That kind of cuts us off at
No, but here's
it's
the
the
thing.
stuff that we can't access by definition.
Yes, but
We just
here's the
don't have
thing.
access to it.
Here's the thing: is how can you claim that any particular piece of knowledge is part of that?
What? No
So,
particular
like-
part of knowledge is it?
No. Like when we're talking about a particular thing that we're trying to understand, right? And you or someone else who I'm arguing with says to me, right, well, actually, what we're talking about right now is part of the noumenon, and we just cannot know.
No, it's not.
And
Everything we talk about
linguistics is
is
insufficient. I've heard you say that. Linguistics is insufficient.
yeah. So
Yeah.
what
How
I'm
can
what I
you
mean
how can you
hang
make
on.
that claim?
what I'm saying. Sorry, I like need to rehash and then like improve how I speak. That's what's happening here. So what I'm
Sorry if
what
that's
I'm
the
saying
case.
what I'm saying.
Yeah.
Yeah, sure. It's what I need to do. It's good. That's why I
Of
talk
course.
to people.
Yes.
What I'm saying is that what we're always discussing is phenomenon, right? We discuss
Not
the
always.
phenomenal world.
Yes, no,
We're
but
always
think about
discussing
this.
phenomenal
Think
world,
about this, right? Like
right?
that. No, I understand, right? But the thing is that
Yeah.
maybe you can access rationally things that you have absolutely no physical means of getting to by thinking carefully enough about what you
So-
do have access to.
All you will have done is found a pattern in your phenomenal world.
Yes,
That's
but
what it is,
maybe, also, listen, maybe the pattern you found was in the actual world.
Yes, and that's all you can say. We're stuck at maybe. We're not stuck
Yes,
at
but
it
no,
is
but listen.
or it
No, but
isn't.
if,
It's just
if
maybe.
listen, man. Once I get you to maybe, then we're talking about what it would take for us to recognize that we have an answer to the question, and then we're talking about whether or not you accept the answer to the question that I can provide.
Okay, so
Yes.
what I'm saying is we have the phenomenal world, which we can talk about, discuss, and all that stuff.
Mm-hmm.
The noumenal world, about which we can conjecture, but we're always just stuck at conjecture. It's always just
Not
maybe.
really.
It's
There are
maybe
there are
this, maybe right?
states of perception where you can experience like you see
There
the
is
Yeah.
how we
more.
process
Listen.
information.
There is more justifiably compelling conjecture and less
Hmm.
justifiably compelling conjecture.
Yeah, but conjecture,
No, but
regardless.
the thing is that, okay, so let me give you an example. If I can give you a piece of conjecture, right, that like stands like over like a 250-year period as like irrefutable, right? You would say that even though it's conjecture which hasn't been proven or demonstrated, the fact that no one has been able to figure out how to say that it is wrong is some sort of evidence to indicate that it might be correct.
Yes, of the phenomenal world.
No, but you can make those propositions about the world about which you cannot know, and the irrefutability of something is evidence for the correctness of the proposition.
So, if what we're saying has any relationship to human sense and or perception, it is about the phenomenal world, not the noumenal world.
Yes,
Right?
but you can reason about what you might call the noumenal world.
Can you
Like
reason
it's
about
not
something
just conjecture.
you
You can reason about it. Yes.
I mean, you
See,
can reason about what it might be, but not what
you
it
can
is.
reason about what the formula of what it is.
Might be. Yeah.
No. You can like look at things and consider them in general and come up with what the actual formula of a thing is. Even if there's no way for you to know
Right.
such a thing,
So
it's possible
all
for you to conceive of the correct answer.
right, yeah. So that's still in the phenomenal world, right?
No, but
It's
no.
not-
But then you may have knowledge about which you cannot know, you do not know. You may have the answer and never be able to say this is technically the answer, and you can show that it is, but you may nonetheless have it. That's the point. Like, you can describe it accurately, even if you can never know such a thing to be accurate.
But can you?
I think so. Why should you think otherwise?
Paradoxes?
Paradoxes are people being confused about language, dude.
Exactly, you're people.
Yeah, so people being confused about language is not evidence that there are actually contradictions in the world.
Where is the line between confusion and what is true?
Well, like, people make linguistic statements which attempt to represent the world. The fact that people can make statements.
Linguistics, dude. Fuck
That
linguistics.
is what we're
Like,
talking about. We're talking about paradoxes are linguistic confusions, man.
okay, let's like
Listen, dude.
hypothetically-
Reality doesn't have any fucking paradoxes.
dude,
Reality is
hypothetically-
contradiction free, bro. Contradiction free, 100% guarantee.
Contradiction free because it has to be.
No doubt, dude. That's
Yeah,
because
no.
it's reality.
Yeah, no. This is
Like,
we have like slightly different metaphysics. So in my sense of right, you got the phenomenal world and we got layers of description of that, right? But the layers of description of phenomenal. A natural accident is to think that I have this layer, right? And
the
maybe
patterns, dude, the correlations and the patterns are the most significant, right?
Don't you think, for instance, wait a minute, don't you think, like, when you have this pattern, a good inference is to say, okay, so there's this pattern, there has to be a world that the pattern represents.
I mean that's an inference.
It's like a
Good.
certain
It
blinking represents your
seems like a pretty strong inference, though.
Yeah, it's a nice inference, but it is an it's an inductive inference. It's a nice inductive.
I accept that. Presumably, we accept induction as a method to try to get to truth.
Try but fail.
No, but the point is, we don't have to know that it's true. That's exactly what I said, right? I'm talking
Right.
about reasoning about the world about which we cannot know. So when the standard cannot be conclusive demonstration, what we're saying is, let's try to get a compelling argument about what we're talking about.
Now if you're talking about like confidence, then that's different, right?
But it's not exactly confidence, right? If an argument is abductively derived and deductively valid, and like the abductive derivation goes a long time without having any flaw demonstrated in it, then that's extremely compelling. And like, there's no reason that you wouldn't treat it as true.
Yeah, I think if you rework epistemology such that confidence is truth, then yeah, sure.
No,
Why not?
dude. I'm saying that in the realm of ontology, confidence is the best standard that is available to you.
Okay, yeah, sure. But I just wouldn't call it truth anymore. I just call it confidence. That's what I just do.
I mean,
Truth
that's
just
basically,
disappears.
then you call all truth confidence, dude, because humans know nothing epistemologically.
No,
Yes, but
there's some things that
the
are.
pattern remains. Whatever
okay.
we say, the pattern remains.
That's what I said.
You can call it all confidence.
I said
then
that no matter what you call the pattern, to say that there is a pattern is to say that it represents something that it's.
Oh wow, we express things differently in sync.
fine.
Wow.
No, that's just a linguistic quirk. Like the
It's
moment
not a
of
linguistic
expression
quirk.
itself. Yeah.
It is not a linguistic quirk.
The moment saying is
pattern.
that's a linguistic quirk.
It's a quasi crystal.
What?
It's a linguistic quasi crystal.
I love it when like it's the perfect counter argument to analytical philosophy. Those are just linguistic quirks.
No, that's the point of analytical philosophy.
No, it's not.
Analytical philosophy is to ask what questions are garbage because they're not.
That is
treating
not the
linguistics
point.
correctly.
That is not the point.
Oh, okay. What is it to you?
The point of analytical philosophy is to derive meaning from the words themselves.
Like with a linguistic framework.
Mm-hmm.
Thank you for listening. Like, share, subscribe, and join us in the Nameless Debates Discord. We hope to see you there.